All right, guys, this is a little uh, log review. So this is a long time coming, so I apologize that it's so late, but better late than never, right? So I thought I would just do, I would say quick, I hope it's quick, but quick review of logs. Okay, so what is a log and why do we have them? So I'm just going to start with the basics. So if you have something like um, 4 to some power is 27. So 4 to what power is 27? You're like, I have no idea. 4 to what power is 27? I know it's something like 4 squared is 16, 4 cubed is 64. So I know it's 2 point something. So what logs are for is to find what the unknown exponent is. So that's why we say logs are exponents. And you've seen that in the notes. You probably were wondering what that meant. So logs are exponents because it finds the unknown exponent. So then you're probably wondering what this was. So I called it around the world. That's how I think about it. So you write log, like this is base 4 to the power of x equals 27. So I write log base 4 of 27 equals x. So that's what I was doing. So I was like circling it. I was like base 4, always start with the base, of 27 equals x. So log base 4 of 27 equals x. So x is the exponent right there. That x is there. And so that's what I was saying. Logs are exponents. And it works the other way too. So we do something like log base 2 of, we'll make it easy, 8 equals x. Okay. So here we're finding the unknown exponent. So I do around the world again. And like I said a second ago, I start with the base. So base 2 around the world to the power of x equals 8. So what does x equal? And you guys all know x equals 3. So 2 to the third power is 8. So logs equal exponents. X is 3, the unknown exponent. So that is logs. So logs and exponentials are inverses of each other because you need to use a log to solve for exponential, and you can turn a log into exponential to solve. So that's why they're inverse of each other and they go together. So let's go back to this one. Let's review this one. So in the notes, like you can use the calculator. And then it was called change of base. So you're changing it to base 10. So the change of base was log of 27 over log of 4. So that's called change of base. And all this is a way to type it into the calculator. So let's pull up my screen. So it'd be, what was it, log? Where we at? Log of 27 entered divided by log of 4. So 2.377. So this one right here is x equals 2.377. So that's what we said a second ago in the beginning when I was like, it was 2 point something because 3 was too big. So that's a general overview of what logs are for and when you use them. So you use logs when you find the unknown exponent. You turn the exponential into a log, and then you have to use a calculator on this part for most of the time when their numbers are hard. Not always though. Like this one's a little simpler. Base 2s are simple. So this one you don't need a calculator because you can just rewrite it as an exponential and then solve it by hand. This one calculator because those numbers are kind of crazy. This one non-calculator. Okay, so that's just a basic rule of thumb of what is a log and exponential. Okay, then let's solve. So solving would be something like this. So let's say 2, to the 5x equals 16. Okay, there's a couple of ways to do this. So I'll show you both ways. So the book, I think, if I remember correctly, it says make them the same base. Well, this is base 2. Can 2 raised to some power of 16? Sure. So 2 to the 5x is the same thing as 2 to the 4th because 2 to the 4th is 16 because 2 times 2 is 4, 8, 16. So now this is called same base. Like you're making them the same base and exponential. Well, you guys remember from Algebra 1, like if they're the same base, then you set the exponents equal to each other. So 5x equals 4, x equals 4/5, which makes sense because 2 to the 5th power would be what? 2 times 2 is 4, 8, 32. So 2 to the 5th power is 32. We want something smaller. So 4/5 is x times 5 would be smaller than 5. So that makes sense. Okay. So this is called making them the same base. So 2/16 does have that in common. Okay. What if it doesn't have it in common? Or let's do something like 2 to the 5x equals, I don't know, 88. I don't know, I'm making this up. Okay, so 2 to what power is 88? And I'm like, I have no idea. I don't think it happens. So then we can take log on both sides. So in the notes later on the lesson, you want to solve this, but you can't use this train of thought because this is base 2. 2 to some power raised to power does not give me 88. So you have to scratch that train of thought. So then in pre-cal, we really don't use this too much. We do what we're about to do. So what I do is I take log on both sides because remember, we're trying to find the unknown exponent. And how do you find unknown exponents? You take logs. So now this really is saying log of 2 to the 5x equals log base 10 of 88. Does that make sense? Okay. So then what do we have here? Now we're using all those power rules and everything. So let me go back and write this like that. Yeah. So now we're trying to solve for x. So if you remember those rules that we had, like this is the power rule. You learn that later. If you move that 5x to the front, that's what the power rule was. Log of 2 equals log of 88. Okay, the cool thing, the x is out of the exponent position. Now it's up front. So now we want to solve for x. So next thing I would do is you would divide by log of 2. So you're left with 5x equals log of 88 divided by log of 2. Well, then you want to get rid of that 5. So how do you get rid of the 5? Times it by 1/5. So 1/5 times log of 88 over log of 2. Okay, so very quickly, I'll type in the calculator. Log of 88 divided by log of 2 divided by, so 1.29. So x equals 1.292. And you could check it. So let's check it. 2 to the power of parentheses 5 times 1.292 is 88. So you can check it. That's a cool thing. You can check it. That's nice. Okay, so let's go back. So this way is making in the same base. This would be more of a non-calculator question because you can make in the same base. So if we would have been in the classroom, we would have had a test with no calculator and you would have had to do same base. But when the numbers get crazy like this, it would have to be a calculator question. You would have to use a calculator. So in pre-cal, you have the calculator quite a bit after the first 9 weeks, but it's good to know both. I'm not sure the SAT, there is a non-calculator section on the SAT, so it's good to know both. Okay, let's do a few more. Okay, what if you have something like, let's do 1/3 to the power of 4x equals 1/27 to the 10 minus x, something like that. Okay, so here again, you want to think about for my first approach, if I had no calculator, this is base 1/3, it's pretty small. Can I make this the same base? So sure. So 1/3 to the 4x equals 1/3. 3 times 3 is 9 cubed. So that's that. All of this to the 10 minus x. Okay. So all you're doing is rewriting this as this right here. You're just rewriting it, but they're the same base. That's what you want. So 1/3 to the 4x equals, well, this is 1/3 power to a power you multiply. So 30 minus 3x, like that. Now, these are the same. 1/3 is the same. So the bases are equal. The exponents are equal, which is awesome. And now you just do math. So it'd be, let's see, I'm going to add 3x over here, which would be what? 7x equals 30. So x equals 30 over 7. And then you can plug it back in and check it. So this was 24(1), 24(2) in the beginning when you were just like trying to get rid of the exponent. So that's what logs are for. If you have e, let's try e, something with e on it. So if you have like 4e to the 5x equals 10. Actually, let's make it easy. Let's make it 12 so we can work it out easier. Okay, so if you have e, it's a little bit different. So you want to get x by itself, but it's of the exponent, so you can't get to it yet because that 4 is there. So you're going to divide by 4 to the 3. Okay, e, you have to use a calculator. You have to use a calculator because what is e? Remember, e is a number. E is 2.718. It's just a number, just like pi. You know how pi is 3.14, blah, 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 blah. That's what e is. E is just a number. Okay, but there's no way 2.718 raised to another number is going to give you 3. So that's not going to work. So what you do here, how do you cancel out e? Well, natural log will cancel out e, and then natural log. So if you do it on one side, you do it on the other side. So that's what I was doing in the notes. I was taking the natural log on both sides. Well, the natural log of e is 1. So this cancels, and you're left with 5x equals natural log of 3. So then x equals natural log of 3 divided by 5, which is, let's see, natural log of 3, enter, divided by 5, enter, 0.22. Okay, which makes sense because that would 2 to the 5th power is pretty big. So that's way too big. So 0.2 makes sense. Okay, piggyback off of that, let's go back to this. We haven't I didn't do video notes on this. So like log base 3 of 3 equals what? Let's find out. So 3 to what power is 3? So 3 to what power is 3? And we all know it's 1. So anytime these numbers are the same, the base number, it always cancels out and it's whatever x is. So like another one was log base, 3, we know it's 1. But what if it was 4, like that? So then it'd be 3 to the power of x equals what? 3 to the power of x equals 3 to the power of 4. Oh, so x equals 4. Well, in my notes, or if you go back and look, the shortcut was this. The shortcut was if you have a log and a base and then of a number, and then it was like this. I think that's what the book was. You saw stuff like this where it just crossed out because whenever you have the same base and that number match, we just proved it here, it's always going to be 1. So this right here cancels out to 1, so the answer is just x. Well, why does that work? Because, let's go here. If you put this x right here, okay, so I'll rewrite it. So log base 4 of 4 to the x. Remember a second ago to the power rule? This is the power rule that you learned. So right here, that would move to the front of the log, right? So it'd be x times log base 4 of 4, which we just learned. Log base 4 of 4 is 1 times x, so the answer is just x. So the power rule is why it crosses out, and it's this answer right here, because the power rule moves the x to the front. And of course, the shortcut is you just cross it out because that's 1, and then whatever this is. But this is really the reasoning behind it. This makes more sense. So this number here got moved to the front, and that's why it worked out. I think that might be in the notes, but I'm sure it was really hard to understand without an explanation. Let's see. I guess I'll keep moving. Actually, I think I'll stop that one and take a moment and then pick up on another one. Okay, I'll be back.